Right, good morning everyone. So I hope you can hear me clearly and also you can see the screen. So please give me some indication that my voice is okay and also the screen is okay on your side. Okay, so just a reminder that we will start our session soon. So I'll give some time for people to come in, and for the meantime, I will share the attendance list as usual. Okay, so please put in your particular, sign up for attendance, and then we will wait for a few more minutes for us to start. Right, so just some logistic thing. So similarly, we will have two sessions today. So the first hour, we will discuss about visual perception in terms of RGB-D sensing. So I will show you like what are the sensors and how to actually get this image and what type of data we want for our robots and what are the application or what are the functions that we can produce from this data. Okay, so for the first hour, we will talk about acquiring the RGB-D sensing data and for the robots to do some processing. And then for the second half, next hour, we will talk about image processing. So I will show you like once you got the data, so what you can do. But today the class is since this is targeting very beginner, so I won't go very deep into image processing or visual perception for robotics. So I'll show you some basics, so let you understand the idea. Yeah, but of course later on we will have more detailed classes that discuss more in depth about robot visions and so on. So um, yeah, so later I will ask around. So if you are interested, maybe you can put down your name as similar to the speech part. That we will have more in-depth vision classes after this, but we need to do some arrangement, right? Okay, so and as a reminder, so this session, so starting this week, we will start to have apply the password for our Zoom session. So just in case your friends or your colleague not able to enter with just the ID, so please inform them that we have added the password for security, and also started last few weeks. So we already like simultaneously make this session online. So we are now live streaming on Facebook as well. So for you, uh, we will appreciate that if you can share this thing with more of your friends in Facebook and so on. And also, if you would like to discuss more about the classes, the content, assignment, or anything, please join our group. So you can go to our page. So over there, you can have the access to our group from there. There's a button there that you can press, then you can enter our group. So the group is our community that you are free to interact with the rest of the member and also with us. So we will, yeah, talk more about service robot, AI learning, and so on over there. So feel free to use the community tools for the communication among us. Okay. Then lastly, before I start, so yeah, almost 5 minutes. So lastly, before I start, as a reminder for privacy, all the video will be recorded. So this session, everything will be recorded, and we will publish online. So whether on our YouTube channel or on our Facebook group, Facebook page, and other channels. So all the social media, we will eventually put everything online. So please take care of your sensitive information. So if you don't want to review your name or anything, so just don't make it appear in this session. Okay, so I would like to start the session. So again, please put down your name if you haven't. Uh, I hope you saw it's in the group chat, the link to the spreadsheet for you to enter your name, right? So please do it so that I know who are attending this session. Okay, let's start. Right, so we start with some refreshment for last week assignment. So we did speech synthesis and also speech recognition last week in the previous class. So we understand how to make the robots or your machine able to say something according to the text that you input, and also try to recognize the voice from the human. Right. So although the speech part is not really related to the visual part today, so there are two different modules. But today we are going to use this speech module that you have learned last week to add in the interaction for the application that you are going to build for your vision system. Okay, so I will explain more for today's assignment later on, how you want to make your vision system or vision application interactive by voice with the user. So you will have something that you can talk to your machine or talk to your system, and the machine can do something in terms of visual perception, right? So this will be the fundamental or the prerequisite for today's assignment. But of course, for those that just attended today, yeah, don't worry. These two modules are independent, so you can still proceed with the visual part without knowing anything much about the speech part. But of course, everything is done in ROS, so you still require some background on the ROS, which is the class before the speech that I talk about the ROS subscription and publisher and subscriber, right? So to pass the message around. So that is the fundamental that require for today's development. Okay, and also I'm not sure that anyone have a challenge or attempt the assignment and you have put up your results on GitHub. So if you do so, we would like to have a look, right? We really like we're very curious, like I'm not sure like what result you actually obtain after following this session. So we really wish to know like how much you can achieve with this session. So please, if you have some result and you have attempted the assignment, you face problem, or you succeed, create something interesting, feel free to share with us. Okay, so you can do that through our Facebook group, or you can contact me directly as well. Just email me or anything. You can like send me a chat in Facebook or anything. But yes, so if you can share in our group and we can discuss over there, that would be much appreciated. Okay, right. Okay. So for today's development, these are the hardware and software that you need in order to do your development. Okay. So as similar to the announcement that I made, so you just need a laptop, which is the laptop that we have set up for our Ubuntu and also ROS system. So that laptop is what you need. Then we need the webcam. Okay, so I assume now all the modern laptop will have an internal webcam attached on it, I assume, right? But just in case that you don't have, so you can easily obtain one, just a very normal, and no need to be very high resolution. In fact, the image processing don't require like high definition images for the processing. So we use just a very normal webcam, a USB webcam, those that maybe not even require much software, or you need to additionally add in driver for it to work. So just get a normal webcam is sufficient for this class. Right, and optionally, I will add in some discussion and also share with you some example about the application of using the depth sensor. So we have this RGB-D sensor that available commercially that you can purchase, or maybe you have it in your labs and so on. So if you have those kind of sensors, whether it's a Kinect sensor, Astra sensor, Action Pro, Asus, or anything like real sand. Real sand, maybe you require some more extra effort to put in the driver and so on. But yeah, these are all the sensors that optionally, if you have, you can actually use it for this class. Okay, but don't worry, if you don't have any of those, you just need your laptop and webcam, and you can try the example that I'm going to show you after this. Right, and as usual, we need the software in terms of like need the Ubuntu system, and then on top of that, you need the raw schematic. So that one we already set up. So for those newcomer, so these are the things that we need, and all the related component software. So I'm going to introduce after this one by one as we proceed with the class. Then you can download, and I think almost all this software are all open source, so you can download and install along this class. Right. Okay. So let me start introduce the sensors that we normally use in a social robot or robot. Okay. So for robot vision sensors, it is optical and camera-based system. So it uses the optics behavior to create to obtain the data of the surrounding. Then for mobile robots, because service robot usually we start with a mobile base. So for mobile robots, we use a lot of this laser rangefinder in order to get the distance. So for vision system, the sensors that we use for robot vision will have various function and application. Okay. The most fundamental one for mobile robots is like we use this kind of visual-based sensor for distance detection or distance measuring. Okay, to measure the distance around the robots. Okay, that is for the navigation part, because the robot need to see the surrounding in order to build the maps, in order to be able to navigate around. So that is the first thing that the robot needs to have data of the surrounding in order for it to move around. So that is a fundamental. So we have a lot of like laser rangefinder, ultrasonic distance sensor, and so on. Okay, so you can see like we have 2D laser rangefinder and 3D laser rangefinder. So laser rangefinder is basically to measure the distance from the robots to the surrounding, whether it's a wall, obstacle, or anything, right? So in order for the robots to able to navigate around. So that is one of the very popular usage of visual-based sensor in robots. Then lately we have this RGB-D sensor, which is very, very useful for our robots in terms of not just for the navigation, but for other things as well. For example, like you add in a color-based or camera-based sensor, then the robot start to able to not just see the distance, but also the color information. So you able, and also from 2D to 3D, so you have a 3D image of the surrounding. So from there, we can actually see more things. We have more information. So you can start to not just knowing the distance, but also we can start to use algorithm to understand what are those things. Okay, so we can process the data to understand that whether it's a furniture in front of you, is a human in front of you. You can see the faces, you can recognize who are those people, and so on. So eventually we have the vision that used for face recognition, people recognition, object detection, object recognition, and so on. So we can use a camera, color camera. For example, I show you some example over there. We can have using webcam or Raspberry Pi camera and so on. So all those very small camera, you can use it for to detect, to get the color information in order to do some recognition. Then I also show you one example with on the lower right hand side, which is the Kinect. This is the Kinect Xbox 360 Kinect sensor, Kinect 360 Xbox sensor. Then later on, because this product was discontinued, so no longer in production, but Microsoft actually have new version of this, the Kinect One and so on. But after this product been made, actually it gets a lot of attention in robotics community because of the very versatile application, and also a very, how to say, rich and very reliable sensor data, the RGB-D sensor data that that is very useful for robotics development, right? So I will talk more about this RGB-D sensor, and this session we will mainly focus on this. But just in case you don't have this sensor, you can use just the webcam. So the difference is just that one is for this one, the RGB-D sensor is actually one color or camera sensor plus the depth sensor, the distance sensor. Okay, so that you can have the RGB from the camera side and the D from the distance sensor side. Okay, so we have, when you put two together, we become a RGB-D sensor. So let me show you an example. So this is the specification of the Kinect sensor, Microsoft Kinect sensor. It has a RGB color VGA video camera, so similar like your webcam. Then you have the depth sensor, which is comprised of infrared projector and also monochrome CMOS sensor. So CMOS sensor is the one that in your camera as well, but this one is monochrome, so it actually black and white. But it is using infrared over here for the projection. So it is actually a projection. It's different from 2D laser rangefinder where you have just one plane of data, but this one is a projection. So projection is like your projector, and you can see the range or the region covered by the sensor on the right hand side. So the distance is about, you can see there are two different colors, so the gray color and the blue color. So the blue color is the effective region. So from the sensor to the object or the people, you can see from starting from the sensor to almost 1.2 meter, those are actually not visible in the sensor. So it requires some distance from the sensor in order to be visible. And the range is about 1.2 to 3.5 meters. So it is very similar like how you place your Xbox and you're standing in front of your TV to do the dancing game, right? So that distance is what the robot will use for the detection as well. So it is very much nice range for indoor application. So these sensors are not for outdoor use, right? Because of very weak intensity, which is like it's using an infrared, so it can't really, like, if you have sunlight, the disturbance is very high because the sunlight is much stronger than the infrared, and also the detection range is it's not very far, so it's like within a few meters. So it is not suitable for very rapid moving robots, for example, like your autonomous car. So it requires much longer range from a few, not really, 100, yeah, almost 100 meters to even like longer for fast moving outdoor application, right? So this sensor, although the spec is not very high, but it's really very suitable for indoor application, and also because of this low requirement in the range and so on. So this sensor it can be made very cheaply, so we can use it a lot in our indoor robotics application. So it's a very ideal solution for robots in order to do visual perception for indoor application, right? Okay. Right, so start with some basic concept about visual perception. So the first thing is distance sensing, right? So the distance to the object, so you have a sensor, which is usually you have a transmitter and receiver, and what it transmits is the light, right? Whether it's an infrared or whether it's a laser, so it uses the same optics behavior, which is the distance of to the object is measured using the time, which is the time of flight, so TOF. So maybe you come across this keyword frequently when you search some information about distance sensing. So this TOF is the time for the light beam emitted from the transmitter and hit the object and then return to the receiver. So with a very simple equation over there, so you can see like the length is equals to the velocity times the time taken for this one cycle and divide by 2. Why divide by 2 is because the distance is like it traveled to the object and it come back. So you have 2 times the travel. So you divide by 2. So the length is half of this time. Okay, so it is a very straightforward and simple equation that can understand. So this is the fundamental concept of how we use the light to measure the distance. Okay, so this is one of the very basic equation that you need to know. Right. Then the second thing, so we have the distance. So how about the color sensing, right? So for the color sensing, it is similar like how a camera sensor works. So you might heard about CCD, you might heard about CMOS. So CMOS, CCD are the sensors, the imaging sensors of the camera. So for the imaging element, which is you can see from the right hand side, the one on the top, the black color one, it is look like a CMOS or CCD sensor, right? So on top of the sensor, it actually has a lot of photodiode or something that is sensitive to light, right? So it will detect the intensity of the light. So you can see what those some tiny little piece on the black color sensor is like it receives the light and then it will measure, or because it's sensitive to light, so you know like the behavior of the photodiode is like it will measure or it will convert the light intensity. So how dense or how bright is your light, so it convert that into electrical signal. So that is the fundamental concept how this component in the sensor work, right? So it convert into electric signal. Then it's used this photodiode, and not just the intensity of the light, but we also know about the color. So how the color is being extracted is we use this color filter. So you can see over there. So we have a Bayesian filter and so on. There are many design of the for this filtering, but it looks almost same like this. So we have different colors on this photodiode that it filter out. For example, like you have the red, um, you have the red. So these three fundamental color, which is the red, the green, and the blue. So that's why you have RGB, right? RGB. So these three colors, it will filter out. So it will filter out the light in order to get the intensity of the red, the intensity of the green, the intensity of the blue. So that's why the raw sensor data that you will get is in terms of RGB. How much is red and how much is green and how much is blue in all the pixels. So we call it pixel in all the dots. So these are all the pixels. So if you have more of this pixel, then your image becomes sharper, right? Image becomes sharper. And the range, so the pixel value is 256 level. So you have from 0 to 255. So that is the value for you to define the intensity of the red color or intensity of the green and also the blue, right? So from there, we collect all this information and then we can patch together into a big array, so that array become your image, your digital image. Okay, so you can read more from the reference that I put there. You can read more from there, the detail. So I just tell you very basic thing about how this color sensor works. And this is the imaging sensor in your camera to get the information of the light. Okay, right. So yeah, then once we have the distance information, we have the color information, which is the images, then we can do digital image processing. So digital image processing is to process digital images through an algorithm. So you can use any algorithm in order to process your image to get certain data. So this is the image processing in general, right? And it has a lot of functionality, or the task can be accomplished by this digital image processing. So for example, you can do classification. Classification in many form, right? In many form, you can classify different color. You can, as a very basic, you can classify different colors, and eventually you can classify different objects and so on. Then feature extraction. Feature extraction is like you can get specifically, for example, what is the contour or the outline of certain thing, and so on. So this feature extraction is very, very important. For example, you get the features of a face. For example, like you find out where's the eyes, where's the ears, where's the nose, where's the all these things. So from this feature extraction, which is some unique point in one of the image, that you can do some recognition later on based on these features. Okay. Then multi-scale signal, and so signal processing is one of the very important subject that support this image processing, because eventually you can convert it become a signal, right? Pattern recognition. Okay, so pattern recognition is one of the very fundamental in image processing. For example, like you can use pattern recognition for handwriting recognition, number plate recognition, words recognitions, and many more. So pattern recognition itself is a very big research domain. Then projections and so on. So there are many things that we can talk about for image processing, but I'm not going to do that today because today is just want to tell you very basic thing, what are all these things, right? So if you're interested, yeah, feel free to explore more, to know more about in-depth about all these things, right? Okay, so I've spent quite some time for all this theory part, right? So the next thing is I would like to discuss so what are those challenges in visual perception for service robot development particularly. So AI learning and service robot application, we have very similar challenges as compared to, for example, computer vision. So you heard about computer vision, you heard about AI learning in visual system and so vision system and so on. So we have many people that do in this research and development. But for us, that we focus more on service robot application, we have some unique features or unique point of view that actually created some difference in terms of our development compared to, for example, computer vision, right? So over here, I would like to show you what are the differences between our development as compared to those people in computer science that do on computer vision. Okay, so we use the same fundamental thing. We use the same sensor. We use the same algorithms and so on. So all the fundamental things are all the same. It's just that for us, when we do our research R&D, do our research and development, we have different point of view in terms of our challenges, especially our challenges mostly motivated by real world application and also real implementation of the algorithm itself. Okay, so let me show you based on the scenario in RoboCup at home. So in RoboCup at home, we are given a game field. For example, like you can see on the right hand side. So we have like a model house. Okay, so a model house with real furniture, real people, real everything real. Okay, the everything is exactly look like your house environment or any public environment. So you can see we use all the real furniture and we try to arrange out like a living room, bedroom, kitchen, and so on. So we use this as our indoor environment. So this is our definition of what is an indoor environment. So this is how it looks like. Okay, so we are going to build our application based on this environment, and also for those objects that in our interest are the typical daily life objects that you need to build daily, right? So for example, your snack, for example, your drinks, your food, or any things that you can find in your kitchen, any things that you can find in your living room, and so on. So these are all the objects that we concern in our service robot development, right? And also not just the objects, but also the people. So you can see like on the right hand side, there are people's around. So it's similar like in your house, you have your family running around the house. And so the robot able to not just recognize the environment and also the objects and also the people that is around. And also maybe you have a pet, you have a cat, you have a dog in your house, or any other types of pets. The robot need to be able to see all these people and understand what are those things and how to interact with all these things, right? So for our challenges, so we define these are the places, objects, people, and any things that we need to use our vision system in order to see and understand this thing, right? So in order for us to create our application, so this define our development boundary. So we see all these things. So it's very different. Like if you put a different scenario, for example, I compare to, like, for example, autonomous driving, right? So if you compare to autonomous driving, um, you are no longer like want to recognize furniture, but you are more concerned on all the things in road on the road. For example, like other vehicles, the lane, uh, signal, traffic signal, traffic signboard, and also the people. For example, you have traffic police, and you have people that crossing the road and so on. So everything is very different, and also the speed, because the robot, for example, like, it's very different. In computer science or computer vision, usually the camera don't move, right? So you look at one object and you try to recognize. So that is in computer science. Then when you come to service robot, the robot start to move. So your camera also start to move. So you can see like our objects no longer statics. Like from far, you can see a person like very tiny. Then as nearer, maybe you can just see the face and so on. So the distance, the orientation, everything change as the robot moves. Then if you change again a scenario to like autonomous driving, everything is moving very fast. For example, like you try to imagine the car is moving like 80 kilometers per hour. So everything is moving very fast. So your detection have to be very rapid in order to catch up all this. So when all this movement changes, it actually make the recognition or the image processing difference, because how the data feed into the camera will become very different as compared to the fundamental, like you have a static object and your camera is static and looking at the object. So it's very different. Okay, so these are the challenges or the point of view that I wish you to understand in our development. Right. Then when we want to see, so what are the actual application that we require in service robot? Okay, so if you are interested to know, so what are the things that we tested in RoboCup at home, so you can find the rules that you can read the tasks. We have this competition task that will gauge the visual or the vision functionality of the robots. In, for example, the first one, the speech and person recognition. So over there, we have this person recognition that the robot uh, need to, how to say, perform, right? Okay. Then we also have this another task called sorting grocery, which is the robot need to see those things on the shelf and also on the table and try to sort those things that is scattered around on the table in order to place according to the category in the cabinet. Right, so you have like the drinks category, the snack categories, the tools category, the fruits categories, and so on, a magazine and so on. So how are you going to understand this thing, try to sort them up, classify them into different classes, and put them accordingly, right? And for the person recognition on the left, right hand side, you can see like we need to recognize not just people that we know, which is the robot know, also need to recognize the people that the robot never seen before, right? So pattern matching or very classic pattern matching approach is no longer sufficient for today's task. I mean, like in our visual perception challenge in service robot. So it need to recognize unknown people, and also it need to recognize the gender of the unknown person, right? So this person you never seen before, but you can recognize, like, okay, you can estimate like it's a male or female. So how the robot able to do that, right? And also the robot need to able to recognize also people that is in the database or the robot knows. For example, the master or the family members, and also the strangers and so on. So you need to understand all these things. So just face detection and recognition, we have a lot of different criteria in it, whether you have the data or you don't have the data, but you still need to know, like for example, the features, whether the type of the color, the color of the hands, the color of the eyes, the anything. So the features, for example, like uh, what is the color of the dress and so on. So these are all the challenges in at home for to test how much the robot able to see the surrounding and also understand. Understand means, okay, you see something, then you understand that, okay, this is a person, and then it's someone that I know or I don't know, and then okay, like what is the color of the hair, what's the color of the shirts, and so on, right? So these are all the challenges, and also the target application that we want to build. Right. So almost 36 good. So for the next 30 minutes, I'm going to show you how to actually start working uh, on robot vision with ROS. Okay, so we will start this part. All right. So I will, by 11, so I will show you until the part that how we can get the sensor data and also how to put this data into ROS and get ready for our processing. Right? So I will show you how you can use your raw system in order to obtain the data from the sensor and then process this sensor data into some meaningful way so that it is ready for you to do the processing, which means you can see the data, right? Then the next part, the next hour, I'll explain about how you can understand the data. So this part is how you can get the data and in a very structured form in your system. Okay, so in order to do that, you need a few tools. Okay, as usual, I will explain to you what are the tools that is required in ROS in order for you to do robot vision. Okay, so the first three things, so we have OpenNI tool, OpenKinex, PLC, OpenCV, and all these things. So for these three, the top three, okay. So for OpenNI, OpenKinex, and PLC, these are the three what we call driver libraries and so on, in order to for your robot and also your sensor to acquire the data and also to process the data into something that is structured and meaningful. Right? For example, you acquire raw data like analog data from your camera, then you need to like process it so that it become very nice digital image or a video stream, and then you can apply your algorithm in order to do the processing. Okay, so the first thing is you need to have all these things, but don't worry, you don't need to do anything because when you install ROS, you almost have all these things. Okay, you already have all these things. But I show it over here is for you to understand that we are using this tool, and if you want to know, you can go to the respective page to read more. Okay, but I will just briefly tell you what are these things. So for OpenNI, basically it's used for Kinex or the Astrea. Okay, Kinex sensor or the Astrea sensor, which is the RGB-D sensors that we use. So if you're using USB cam, most of the time you don't use this driver, but you use other driver, right? But for OpenNI and OpenKinex, these are the driver that we use it for our RGB-D sensor. So if you're using the Kinex sensor that just I show you, or the equivalent sensor. The equivalent sensor means, for example, okay, in the real sense, you might need a different package in for the drivers and so on. And then over here, we use the Astrea sensor, which is we also need the Astrea package for the driver and so on. But this OpenNI and OpenKinex actually, how to say, provide you the driver in order to do some simple processing. For example, like how you want to obtain the how to say the 3D image. Okay, so you can have the RGB-D color, RGB-D sensor, and also the depth data, and then you can put these two together. So the depth data is something that how much distance each pixel from each point, right? Right. Okay. So later I will show you like how this thing look like. And then the third one, the PLC and the PCL, which is the point cloud library, is the library that try to help process the 3D data to give you the point something similar like a cloud. Okay. So which means later on you will see we actually have a lot of dot in the space that represent the point where the infrared lights hits the object. Then it will create something like a 3D model of the particular object that the sensor detected. Okay, right. So these are the three libraries that we use it for our vision, our data processing. Then OpenCV. So this one is a very important and popular open computer vision library that a lot of people use in whether it's a computer science, computer vision community, and also for robotics communities that we use a lot library in this OpenCV uh, in order to do. It's a large collection of algorithms for image processing, computer vision, right? Not just image processing, but also for the uh, depth sensor, data processing, and so on. So yeah, so a lot we use. So we will show you how to use all those things, and then so this is so if you want to know, for example, like you're interested in the algorithm, for example, you want to know like exactly how the face recognition is done. So what are the theory behind, what is the calculation algorithm that we use, and so on. For example, later on we will show you like the cascaded algorithm and so on. So if you are interested on all those things, you can head to this OpenCV website to look for respective algorithm or calculation method that they use in all the example. So we use a lot of OpenCV example, so you can always track back to the OpenCV site to find out what exactly the algorithm that you use for certain application, right? So this is a link that you can go and find out. Okay, so in order to let you get started with OpenCV in a very rapid way, okay, in a very, we need to cut a lot of the fundamental things that, for example, if you want to work with OpenCV from scratch, it is a very lengthy process. So we use ROS OpenCV application library, which is over here that this library package or wrap the OpenCV example nicely into ROS. So which means you can directly use this library to run certain function instantaneously, right? Right after you finish install, you're already able to run. And yeah, you have everything done for you. But of course, if you want to do some modification or you want to start to modify the example to build your application, then you need to understand the underlayer um, algorithm and also the coding inside there. But this will be a very, how to say, um, rapid start for you. Okay. Also, I can say like you can start your application right after this class. Right. So without actually start to build the OpenCV library, start to get your data into OpenCV and start to understand all the function, how to do the, yeah, you can skip all those things for this class in order for you to first test how does it look like, then try to work out with the example. And when you are comfortable, of course, you are feel free and welcome to go back to the basic and start from the very basic. Yeah, of course you can do that. But yeah, I will show you the easier way first. Then later on, you can explore more by yourself. Right. So in order to start, we will, as usual, I'll show you like the installation and also how to set up and to bring up. So let me connect to my robots. Okay, so I hope you also get ready your laptops with your system so that you can do it together. Okay, let me put this thing down. Okay, so as a reminder, I have about 28 in my list, Zoom list. So please sign up yourself, put down your name. Okay, I will send this again. So in the chat, so please sign up, put down your name so that I know who attended. Okay, right. So I have my Ubuntu over here, right? Then this one. going to make it smaller. Okay, right, so I need to use this. And I have slide number, this one. Okay, I'll take this thing out, make this like this so that you can see. Okay, right. Okay, right. So we have something like right. So the first thing is you want the Astra. Okay, so I don't think any of you using this sensor don't. So it's okay because I'm using this sensor on my robot. So I show you the things. But the first thing is you need to install your USB camera. Okay, so you need to install your camera, which is for me I don't install because I don't have a USB camera on my robots, but it has other cameras on it, right? But for you, you need to start by installing this apt get install ROS kinetic USB cam. All right. So I don't install this because I don't use this on my system. Currently, this is my robots. So on my robots, I actually have two RGB-D sensor, which is the Astra sensor. So I use the camera features in the RGB-D sensor to show you the development today. So for you, if you just have a webcam, right? So you can use this. So we are using the ROS Kinetic generic USB camera driver for all the common driver for all the common webcam that available in the market. But I'm not sure what USB camera you're using. Some of them might require not only this but other driver, right? So that one maybe you need to figure out by yourself, or we can discuss in the chat later on. But first thing is like first try to install this, right? So this is a generic driver for all the USB camera. So you install the ROS Kinetic USB camera. So please install this. Okay, run this and then you install, and hopefully this driver able to drive your webcam, right? But it might not able to give you all the functionality. For example, like your webcam have a specific high definition features or autofocus or any other things. Uh, Maybe your webcam come with microphone and other things, microphone array and so other things. So maybe this driver don't give you all those functionality, but at least this driver can get the basic image from your camera, and that is sufficient for our development over here. But if you know exactly which camera you use and you know exactly what driver is suitable for your webcam in Linux environment, so you need to find a Linux driver, not the Windows. The Windows is not going to work here. So you need the Linux version in order for you to interface with your webcam, which is how to get the data from the webcam, right? So if it don't work, I mean, like if you install this and it don't work with your webcam, then we need to figure out other way. Okay, so for example, for one, which is for high definition, is the UVC camera or something. That is another driver for high definition images and so on, right? So you need to install this. Then after that, you need to install the OpenCV application example. So the same thing is very similar like how you install the example that we prepare for you. So first is like you go to your CatKing workspace. So I hope by now you have no problem with your workspace anymore. So you hit to the source, then you clone, right? So you git clone. You can download, but I always recommend you to use git clone instead of you go to the website, you try to uh, download the zip file and unzip and so on. Okay, so instead of doing that, I recommend you to use this way, right? So you git clone this thing, okay? Then you go to your catkin root, which is the catkin folder, just right below. Then you do a make, right, which is you build the thing. Okay, so and this make I think is very important. It's because a lot of this OpenCV app's source code are written in C++. Okay, so you need the make in order for all this thing to work. Okay, right. So please do this thing. So for me, I already done this, so I can show you. So if you go to your raw CD, your OpenCV, oops, Okay, so I already have this in my source. So you can see these are all the things that I have. Okay, right. So these are the thing. So when talking about this, I want to show you this thing. So GitHub. Okay, but instead of this is ROS perception. Yes. So that particular library is something that we use. Uh, so yeah. So this is the OpenCV apps. So you actually download from here. So you're downloading this whole thing. Okay, right. And for this one, you can hit to the ROS Wiki page to see the description, right? So I will briefly tell you, and later on I will show you something more detail. So over here you can see, okay, maybe it's a bit too small. Okay, so you can see like it actually provide various nodes that run internally OpenCV functionality and publish the result as ROS topic. So which means it already like wrap the whole thing nicely for you. The OpenCV functionality, for example, like the classic face recognition, face detections, object detections, and so on, and put the result into ROS topic, which means you don't need to do anything. You just run it and you can get the result, just like your speech. Remember the LM example? So you just run the LM example without changing any of the code, and instantly you can get the result from the LM data, which is the recognized word topic result in the ROS topic. So you can just subscribe to that topic and start building your application. So yeah, so the same thing for this. So this will give you this, and you can see inside here, it do quite a lot of things. For example, like you have the age detection nodes that give you all the. I'm not sure if you need all these things, but I'm sure because personally I didn't do a lot of image processing or so on application in my R&D. But I understand that a lot of people from computer science, doing computer vision, you need all these things like age detections and so on, and also to find the contour and all the stuff. These are the things that you need. And for me, my interest is like, okay, so how to do the face detection, recognition, and so on. And yeah, if you want to go into like a little bit more detail, for example, like this good features tracking. So you want to do like face tracking, right? Face tracking, and you want to optimize. So you don't do detection every frame, but you do like features tracking and so on. So these are the things that you do, IK flow and so on. And personally, I use this cam shift for color detection or color tracking. Okay, color tracking and segmentation and also filtering, right? So just in case you need to do the processing of the color image in terms of not RGB space, but in other things, for example, like HLS or HSV, which is more popular HSV, particularly if you want to do a lot of, for example, like deep learning based object detection. So you need the color space in a different space, the huge saturated and some other thing. I cannot remember what is this variation. If I'm not mistaken. Right. So you can use all those things. So these are all the basic features in computer visions that you can use to process your images straight using these tools. Okay. Right. So later on, I will highlight a few that we can use to solve our task in at home. I'll show it to you in the second half of this session. Right. Right. So over here, so these are the things that you're interested, and okay, you can head to the, if I'm not mistaken, yeah, you might be you will ask me like where are all those source code. So the source code are all open source. So these are all the CPP code that you can modify, right, for your application. But of course, if you don't modify, you just subscribe to the result. You can still do a lot of things. Okay, right. So you install this example. So yeah, I have all the example with me. Then I'll skip this multiple Astra since you're not using Astria. So I'll just skip this. This Astria actually, okay. But I still put it here is because just in case you have multiple webcam or multiple camera, okay, I'm not sure, but some of you will work with multiple camera. So how you want to define your camera, camera one and camera two and so on, how you want to make sure that they are not conflict into the same topic, and so on. So as an example, I show you how I do with multiple Astra. So I have two Astra, one for the navigation and one for the human interaction. So one is on the below for the navigation, one on top for the human robot interactions, face detection, and so on. So this is the way how I do it so that I can have two cameras running simultaneously and not conflict in the ROS topic and so on. So how I do it. So you can see this example as a guideline. So just in case later on you might need more than one camera. Okay. Oh, sorry. Okay, so at the last of my slide before we enter the break, so I show you how I use the library and the driver to bring up. Bring up means I think by now you know what is bring up. So it's just to run all the function, run all the sensors and driver and so on, so that make your system ready to serve you, right? Ready, like for example, for the speech, you have the sound play node that you need to run the sound play node before you can ask the robot to say something. So the same thing for vision system, we need to bring up the sensor. So you need to on the sensor, start to get the data. You need to run the driver, start to process the data and put all the processed data into the topics ready for you to do your application, right? So I list down 4 types of bring up. So if you're using Astra, which is or any equivalent sensor, so this is how you launch bring up. So if you're using the old Kinect sensor, which is I think some of you still using. Oops, sorry. So this is how you bring up. So choose one of this, not type all four. Okay, please just run one of these that relevant to your system, because I'm not sure which system you use, so I list down everything. Then for multiple Astra, okay, I have written the how you want to run more than one camera. So this is the example. You can refer to my source code in my folder, in my example, to see how I put them together. Right. Then for today, I think most of you having webcam, you are going to do this, right? So this ROS launch USB cam, which is you're using the USB cam, which is just now you install for your USB camera. So the package, and also you're using this, you are going to use this USB cam test.launch in order to bring up, right? So for me, since I don't have a webcam, so I can't show you the webcam way. So please, for you, please type this thing and run it, okay? So we can run it over the break. For me, I'm using the first one or the last one. Okay, I'm using the last one because I need to show you both. So I'm using the last one, Vision multi-Astra. Okay, so I'm doing this, so I'm running. So if you don't have anything in red, which means it's good. Okay, so if you see any message in red, then something is not right, right? Okay, so I'm clear, and you can see that I found actually 2 devices. So one is something with the end with 9 and one with end with 8. So I got 2 sensors. Okay, okay, so this is good, but you cannot see anything because like I just run. I mean, I just start my driver and also my sensors and so on. So now the second thing is you want to see what are those data, right? You want to see where is the data and how does it look like. Okay, so let me show you the data. So I'm going to run another one. Okay, so in order to see the data, you need to know what, you need to see what are the topics that flow. Okay, first you need to know your topic. So as the same, do this ROS topic list, and you can see a bunch of topic appear after you bring up. Okay, and over here you can see like we have what we call the camera top. Okay, or maybe I want to like full screen this. We have this camera top and camera and blah 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 and so on. So the first thing you realize is we have one set called camera with all the different type of data, and another set called camera top with a different set of the similar set of data. So this is how I differentiate my camera 1 and 2. So I have the camera which is on the bottom one as a camera topic, start with camera, and my second camera which is placed on the top for human robot interaction. So I call it camera top. So I start with the camera top. And within all this data, inside each of this camera, we have the depth data, which is yeah, the distance data. And another one is called, okay, you're not going to use this IR. These are, okay, yeah, these are not the things that you will use, right? So you use the one RGB. Okay, so you have the RGB, which is the color data, and also the depth data. Okay, okay. Then yeah. Then how to show this how to show this data, because like you can do the echo thing, but because since it is an image frame, you don't want to like publish all the information, right? You don't want to publish it in terms of all the numbers, because it don't make any sense if you print out the RGB value, but you want it to be in a picture form, right? You want to view it as an image. So you can use this, what we call the image view function in ROS to see the image. So I use the ROS run function using the image view package. So inside there, but you need to tell this image view which data or which topic to get the data, right? Right. So from me, so for you, you need to run this. ROS run image view. Okay, you need two image views. Sorry, I missed the image view. Okay. So over here is like I need to use image view package and image view node. Okay, I need to use the node. Then only I put in my argument. Right. And okay. So for you, you need to use this USB cam image raw. You are going to use this as your the topic for your image is because you are using the USB cam, right? You're using the USB cam. For me, I am using this, and some more I have two, because one is the RGB and one is the depth sensor, the depth data, right? So for me, I show you the RGB. Okay, image raw. Oops, where is my image? Okay, I think I typed something wrongly. Okay, I missed the camera. Yep. Yeah. So you can see my hand, and this is pretty low, right? Because I'm showing you the camera below, right? So this is how I get the color image. Okay. Then of course I can show you another set, but you don't have this, okay? Because you only have RGB. Okay, now come. This is so lag. Okay, I don't know why, but okay, this is I want to run another one. Okay, I'm running low in resources, so everything starts to get lag. Come on. Okay, so the second one is I need to type in. Okay, what I need to type in is this. ROS run image view image then this camera. Okay, depth register. Okay, image. No. Okay, so as a comparison, so I have one which is the RGB data, another one is the data from the depth sensor, right? Can you see? And the value for the depth sensor is like the further it is, it become white color. The nearer, it become black color. Okay, so these are the two sensor data that we obtain from our sensor, and it already like processed in a very nice topic, ROS topic. So you can see these are the topics that we define in order to display this. So it's already nicely put in the topic. So we are ready to do the processing. Okay, so whether it's this kind of image processing or this kind of image, this you can treat this as another type of image. So you can process this and get other information as well. Right? Okay, so almost 11. So I'll stop here for the first half. Right? So for the second half, I'm going to show you what you can do with this data. Okay, so I will stop for 10 minutes. So now it's 11:05. So I will come back here by 11:15, right, to show you the second half. Right, thank you, and I'll see you in the next session.